Today we're going to be working on comparing rational numbers, so looking to see if they are larger or smaller or equal to other numbers. And we're going to also put them in certain orders, whether it's least to greatest or greatest to least. So the first thing that I wanted to talk about was how to properly read a number line, especially with the negatives, because some people mess this up. So we have this number line with 6 different points, and we want to say where each point is on the number line. So A would be at -5. B, a lot of people think that it's at -3.5, but it's between the 2 and the 3, which makes it at -2.5. So either -2.5 or -2.5. C is at -2. D is at 1. E is in between 2 and 3, so that's 2.5 or 2.5. F is in between 3 and 4, so that's either 3.5 or 3.5. So one thing to keep in mind, since the -5 is further to the left on the number line than say -2, -5 is smaller than -2. Even though 5 is bigger than 2, negatives are the opposite. -5 is smaller than -2. The next question is multiple choice. It says between which 2 points is 5/16 located. Some people thought, okay, well 7/16 is close to 8/16. And I know 8/16 is half, and L is where half is. So that means 7/16 would be just to the left of it, so it's going to be in between K and L. Another way to think about this is you can count how many lines are in between 0 and 1, and there's 10. So I know I can do 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. If there were 16 lines, then we could just do 1/16, 2/16, 3/16, and so on. But since there's 10 lines rather than 16, it's a little bit trickier. So I'm going to turn 7/16 into a decimal. We do that by dividing. 7 divided by 16. 16 doesn't go into 7, so we put a 0 in our decimal. 16 goes into 70 4 times, and that's going to give us 64. Subtract to get 6, bring down a 0. 16 goes into 60 3 times. And I could be continuing with this, but I actually don't need to, because I know it's going to be 0.43 something. So I can look, okay, where would 0.43 something be? It's going to be somewhere in between 0.4 and 0.5. So that's also where we got K and L. Okay, the next 4 questions we're just going to fill in each blank with less than, greater than, or equal to. When we do this, you need to have a common denominator. You always need a common denominator when comparing fractions. So I have 1/4 and 3/8. The common denominator I want to use here is 8. So I have 1/4. I need it to be an 8. So I need to think 4 times what is going to give me 8, and that's 2. So I multiply the numerator and denominator by 2. So 1 times 2 is 2. So I'm actually comparing 2/8 to 3/8. 3/8 is bigger, so our alligator is going to eat the 3/8. So we can also say 1/4 is less than 3/8. Part B, our common denominator could be 6, since 3 goes into 6 evenly. So we have 2/3. I need to multiply it by something to get denominator of 6. 3 times 2 would give me 6. So multiply the numerator by 2 as well to get 4. So 4/6 compared to 4/6, they're equal. You also could have noticed, well, 4/6, I can reduce this because they're both even. So if I divide both numbers by 2, I get 2/3. So 2/3 is also equal to 2/3. So if you notice you can reduce it, see if that would work as well. Part C, my denominator is going to be 15. So I need to change both numbers. So for 2/3, I need to think, what do I multiply 3 by to get 15? That's 5. So multiply the numerator by 5 as well to get 10. And then on the right, I have 1/5. So I need to think 5 times what would give me 15? And that's 3. So 1 times 3 is 3. So I am comparing 10/15 to 3/15. 10/15 is bigger. Part D, we can either turn the decimal into a fraction or a fraction into a decimal. I feel like most people don't like to do long division, and they already know that 0.075 is 3/4. So I'm going to turn that to 3/4. If you didn't know that was 3/4, you could have put 75 over 100, and then since that's 75 hundredths, and then reduce it to 3/4. So I need a common denominator. I could use 8. So I need to think 4 times 2 would give me 8. So 3 times 2 gives me 6. So 6/8 compared to 7/8, 7/8 is bigger. At the bottom we have a story problem. It says, in a football game, the quarterback completed 11 out of 19 passes. Next week, he completed 60% of his passes. During which game did he complete the greater amount of passes? So 11 out of 19 can be written as 11 over 19. I'm going to compare it to 60%. So I put a line there so it looks like my parts A through D that I just solved. So we can turn 60% into a fraction. If you want, that would be 60 over 100. But then we have some bigger numbers. So I'm actually going to turn 11 over 19 into a decimal. So use long division. 19 doesn't go to 11, so put 0 and your decimal. 19 goes into 110 5 times. And I don't even need to finish any more of this problem because I know 0.5 is 1/2. And I know that 60% is bigger than 1/2. So I know 60% is bigger. So I need to make sure I answer the question completely. It says, during which game did he complete the greater amount of passes? So we're going to say he completed more passes during the 60% game. Okay, moving on to the next page. These next two, we're going to put them in order. It says least to greatest. Sometimes you'll see this written as ascending. So ascending order just means we're going up. So it's least to greatest. If it said descending, that'd be going down. So that would be greatest to least. So a lot of people, they chose to turn each of these into percents because they thought that percents are easier to compare. So 3/4 is 75%. And you could turn them all into fractions, all into decimals, all into percents. It's up to you what you prefer. 0.8, we move the decimal over twice. We have an open spot here, so that is 80%. -1, we have a decimal right here, so we're going to move it over twice to get -100%. Don't forget the negative. 2/5, we could divide to figure out what that is. So 2 divided by 5. 5 doesn't go into 2, so put decimal in at 0. 5 goes into 24 times with a remainder of 0. So we're going to take 0.4, move the decimal over twice to get 40%. And then 65% is already 65%. Okay, so I'm looking for the smallest number, which was -100%. So I look back and that was my -1. So I like to write the numbers how they were originally. So I'm done with this one, so I'm going to cross it out. The next percentage would have been 40, so that was 2/5. The next percentage was 65%. And then 75%, which was 3/4. Then last, 80%, which was 0.8. So this is the order from least to greatest. Our last question for this section, least to greatest, but they are all decimals. I put it on here because some people, they look at 4.4 and they see, oh, that has less numbers than all the rest. That must be the smaller number, but it's actually not. So what I recommend is look for the number that has the most digits. That's 4.009. So we can get all of these to have the same number of digits. So this would be 4.070. So I'm looking for 3 numbers after the decimal. I have 3 numbers after the decimal. 4.4, add a couple zeros. 4.03, add a 0. And this one's already fine. So when I look at this, I'm actually comparing 70, 400, 30, and 9. So the smallest was the 9, so that was 4.009. The next would be 30, so that was 4.03. Next is 70, so 4.07. And last was the 400, so 4.4. Okay. If you have any questions, please email me.